Okay, good afternoon, everybody. Just like to welcome you to our webinar, just the shortage of skills and opportunities in the microelectronics industry. And I suppose this webinar falls nicely in with the EU Year of Skills, and this is all around, I suppose, fresh impetus to upskill and train I suppose, technical staff, but then also, I suppose, reskill for people moving into new sectors or industries. So I suppose it's to encourage that lifelong learning journey and see where that can, I suppose, fit into where the gaps are then out in the workforce. So we've got 4 speakers today who are going to talk to us a little bit about that skilling journey. And with that, we'll be able to slides are a bit slow, sorry. So we have our 4 speakers today, so they're going to give us a bit of perspective on what's required from an industry perspective, what's going on in the microelectronics sector at the moment as well, what kind of skills and upskilling opportunities there are specifically with SkillNet. And then also what's going on in the universities in terms of courses, research, and where the universities can help. Today's webinar is being hosted by the Advanced Centre, and we're a HCI Pillar 3 project. We were set up in 2020, and this is again specifically focused on that Irish industry skills need. The Advanced Centre offers modules all the way through to masters, and the courses available are from level 6 all the way through to level 9, and they're all QQI accredited. So it's breaking up the individual modules that are in masters and making them available in a one-out basis. So you can sign up to your area of interest rather than having to sign up to a full-time program. The aim for the Advanced Centre is to create flexible study and in-company CPD options. And because we're working with the universities are delivering the courses. There's the normal intakes then. So there's a September intake, and then there's the upcoming January intake for our new modules. There's some limited summer availability, so just keep an eye on the website for that. With the Advanced Centre, we're broadly covering digital transformation, and that's under 11 different theme areas. I suppose what's of relevance to today's webinar is the Advanced Electronic System Design theme, and there's a lot of interesting modules going on there, and especially for upskilling opportunities in those areas. So the link is there for the website into that theme. The Advanced Centre itself then is really about, in that kind of context of upskilling and reskilling, it's making sure there's a flexible learner pathway. So making sure people can go back and upskill as easily as possible, and making life easier for people who are out in the workforce, who are trying to get back to education or maybe change sectors. So it's giving you credit for each module you take. Those credits are yours. And if you want to keep adding them up, you can put them towards certificates, diplomas, and masters. So it's kind of spacing out the learning journey so that you can do it at your own pace. But it's also much more flexible. So the aim is to make sure that these courses are online or blended, that the assessments are kind of catering for people who aren't necessarily going to be on campus the whole time. So have a look at that, and that's the type of flexibility we're looking to try and build into the modules. Any questions on that side of things, please get in touch at info@advancedcentre or through the website at theadvancedcentre.ie. If you have any questions during the webinar, please put them into the Q&A section, and we'll try and answer them live or get to them at the end. So I'm just going to introduce our first speaker, Tom O'Dwyer. So he'll come on shortly. Yeah. So we'll hand over control to you, Tom, and I suppose you'll get the ball rolling.
Yeah, that's perfect. Thank you very much, Brendan. I'll just work on sharing here. Okay, can you see the slides okay? Hopefully it's working well.
Yep.
So specifically, I'm going to be talking about the what's called the EU Chips Act and the skills shortage that's been identified as part of this for anybody who's interested in perhaps a change of career, as Brendan mentioned, but also people who are already in the industry and a different format, for example, in electronics, moving across to the electronic side of the house. So just to educate people a little bit on what manufacturing a silicon chip is all about, it basically follows the flow that I've highlighted here. On the left-hand side here, we start out with what's called circuit design, and you're really dealing with schematic diagrams as shown up here at the top. And by using simulation tools, you're able to first order predict what's going to happen when the chip is actually manufactured. It then goes through what's called a layout stage, which takes that schematic and develops an artwork, if you like, which consists of many, many different layers. A silicon chip is made by successively introducing different chemistries into a silicon wafer in well-defined patterns. And these well-defined patterns are illustrated with colors here to represent each individual layer. Then once the layout stage is complete, it goes for what's called mass making. So each individual color then, there's a photographic plate, if you want to express it that way, is produced, which acts as a mask then for light to shine on certain parts of the wafers in order to be able to produce well-defined patterns on the silicon wafer. It then goes into what's called the wafer fabrication stage. And the wafer fabrication stage takes a raw silicon wafer, silicon being basically sand. These days, these discs are about the size of maybe a dinner plate or so. And on each chip, you're able to make hundreds and often thousands of individual integrated circuits, or silicon chips, as they're known in common parlance. So using a diamond saw, then the wafer is cut up once it's manufactured with the various layers that I mentioned back here at the layout stage. Using a diamond saw, each chip is individually diced, as it's called. And then finally, each one of these is encapsulated in a package with these leads, which bring the signals out from the chip to the outside world. So in a nutshell, that's what manufacturing a chip is all about. Now, my presentation is locked here for some reason. I'll try going in again and see what happens. Okay. Right. Now, as regards skill sets, it's actually many and varied, the skills that are used throughout the process. On the left-hand side here, to do with design and circuit layout, we have essentially electronic engineering-based degrees are usually the skill sets that people have. But then there's very specialized knowledge related to specific tools that you need to learn in order to be able to do both the circuit design and the circuit layout stages. The mask making is a very specialized function. I'm not going to dwell too much on that. There's a few companies in the world actually who specialize in this area. It's very much based on optics, mechanical engineering type of skill sets. Onto the fabrication stage then, where you're actually processing the silicon wafers, it's very much applied physics and chemistry skill sets are what's needed there. And then for the packaging stage, in other words, putting the chip in the final plastic encapsulation, this is very much mechanical engineering. And then finally, each package is individually tested, and that's essentially electronic engineering / software type task, with again specialized knowledge required for the equipment that's used to send the stimulus signals into the silicon chip and then read back the responses. So it's quite a wide skill set required to cover the full signal chain. Now, what's this got to do with the CHIPS Act? Well, basically, as a result of essentially the war in Ukraine, especially, they've discovered, and also COVID as well, they discovered that Europe is very exposed to the rest of the world where silicon chips are concerned. So I've shown here a graph of the numbers of millions of wafers per month of these silicon wafers that are produced. And it's dominated very much so by the Asian countries like Taiwan, Korea, Japan, China. The US is up there reasonably well too, but again, that's overshadowed even by China. But you can see the EU is very much the poor relation, despite the fact that we would have one of the largest markets by population. So this has been identified as a major shortcoming for the EU in general, and they're expecting the EU share to grow rapidly, in fact double by by 2030, which is only 7 years away. And they've set themselves a very ambitious plan to expand to meet that need. So down to the particulars then, how much are they putting behind this in terms of funding? Well, the answer is basically 43 billion. Now, this is an enormous sum of money, and it's really unprecedented to invest this much in one particular sector. So in that sense, it's an enormous opportunity that's not only been planned, but also been funded as well to quite a deep level. So it's really divided into three pieces. Pillar one, as they're calling it, has to do with pilot lines and startup companies. They're trying to encourage a lot more startup companies to come into the business. These are engineers who have ideas for a particular silicon chip and who want to basically start their own businesses. Pillar two then really relates to manufacturing capacity within Europe. So this is really the wafer fabrication piece of it, if you like, the processing of the silicon wafer. That's the second pillar. The third pillar then really has to do with monitoring chip movements in the future coming in and out of Europe so that they can respond much more effectively and head off problems before they arise, so that these type of bottlenecks that were encountered previously won't come into play. So the opportunities here are very real and immediate. On the one hand, we have the EU putting up this 43 billion, but the money's already been spent, particularly in Pillar 2, where they're putting a lot of investment into expanding existing facilities. So anybody who's been watching the press in this area would have seen the announcement from Intel, where Intel are opening up an expanded fab in Leixlip in County Kildare. And they're expecting it to raise employment from about 5,000 up to about 6,500. So a lot of technical, highly paid jobs going in this area. Intel in Leixlip would be very much a fabrication plant. So it's applied physics, it's chemistry, electronic engineering. These kind of skill sets are what they're looking for, as well as technicians to maintain the equipment and so on. There's also a big announcement by Analog Devices where they're plowing 630 million to their plant down in Limerick. And again, it's similar to Intel. It's a fabrication plant expansion that's been envisaged there. But in addition to existing players, they're also working very aggressively at the EU level to attract new industries into Europe. And one in particular that's raising a lot of eyebrows is TSMC, which are one of the biggest wafer fabrication plants in the world. They're based in Taiwan. They're actually have set up a joint venture with some European companies, Bosch and Infineon and NXP, to establish a wafer fabrication plant in Dresden. So that's another major development. That will be 2,000 jobs directly involved in that one as well. So that's the existing manufacturing wafer fabrication facilities, but also for startups, for anybody who's interested in, forming their own company. There's quite a lot of effort being put into this area as well. So for anybody out there who is of an entrepreneurial bent, this would be of interest. They've earmarked 2 billion euros to set up what's called a CHIPS fund. And this will be used to support SMEs and startups, SMEs being small and medium enterprises, to get started as independent companies designing their own silicon chips and hopefully leading ultimately to manufacturing sales. So it'll be helping through various expertise training, for example, setting up these competence centers, and also direct financial assistance in trying to form your startup company. So that's really the opportunities there. As I said, it's a 43 billion investment, unprecedented in my lifetime, certainly, in trying to focus in a particular area to expand rapidly to address a strategic need, a strategic weakness in the EU. They're expecting to double the numbers of employees in the business in the next 7 years. Massively ambitious target. and it would rely very heavily on cross-training of people from other disciplines to come across to the microelectronics sector. The opportunities, as I mentioned, exist with both the multinationals that are already established, as well as the startup companies. It's happening on both fronts. And the skills, as I mentioned, cover a broad range, including electronic engineering, applied physics, chemistry, mechanical engineering. So almost if you have any technical discipline, there's probably a position that would suit if you're interested in coming across to this side of things. Now you'll be learning a little bit more from Jerry and the rest of the other speakers about you know, the more direct training programs available. So hopefully that will get you on a specific track for anybody who's interested in following up on this. Okay, and that's the presentation. I'll now stop sharing here and take any questions. We may have had a question during the session, Joanna, is that right?
I think it was just a technical one.
Technical one. Okay, very good.
So no, I think the slides worked and worked for us anyway. So look, if there's any questions on the way through as well, I think we'll have a few minutes at the end to kind of ask a few questions of the group as well. So we'll bring you back at the end.
All right. Okay. Thank you very much.
Thanks, Tom. So look, next speaker I'm going to introduce is Jerry Byrne. And Jerry is the network lead or network manager for Midas, the electronic skillnet or electronic systems skillnet, and he's the founder of Adelix. So I'll hand off to you, Jerry.
Thank you very much, Barry. So yeah, as Barry said, I'm network manager for Midas Electronic Systems Skillnet, which is a training collaboration for the Midas companies for training specific to the microelectronics sector, and it's industry led. So I'm just going to start sharing slides from my side. Bear with me a moment. Okay, is that visible for everyone?
Yep, that's up.
Sorry. So, as said, I'm the network manager of the Midas Electronic Systems Skillnet, and that's also a web link to the Skillnet, which is a sub-activity of Midas Ireland. So Midas Ireland is the industry association, and the Skillnet is the training collaboration. So just briefly about the Midas Skillnet, first of all. So it's industry-led, so we survey the member companies and they provide inputs as to what training needs they have. So that's they provide the training needs analysis. We analyze the survey they've provided. We go through a public procurement competition in order to procure the best trainer for the actual training need. And then the managers from the member companies then assess the actual different tenders that we receive through the public procurement process. So there's a steering group which is comprised of representatives from these 8 companies. Those are actually the steering group members there. And we also set up subcommittees to scope the continuous professional development module. So sometimes there is a need recognized by the steering group that we should try to develop a specific continuous professional development module, usually at level 9, usually about 12 weeks duration, with perhaps 3 or 4 hours of tuition each week during those 12 weeks. And this is just an example of a subcommittee that was formed for the test and measurement CPD module, and again here for the verification CPD module. So what we're actually seeing here is that the companies are coming together to scope these CPD modules, and they're specifically tailored to the training needs of the companies. There's just one more. The key success factor in that is that it's industry led. So the companies feel that the training that is being delivered afterhand is exactly what they have requested. Okay. So the Midas SkillNet was set up in 2018 and has been growing for 5 years. We now run over 60 courses each year. This is just a flavor of some of the courses that are run. So apart from the 12-week CPT modules, there's also some shorter courses in digital design fundamentals, system Verilog, universal verification methodology, analog design fundamentals, specialized analog topics like SR-ADC design, and other advanced analog topics. There's also ancillary training that might be related more useful for data analytics or for the evaluation teams or the test teams, the likes of Python. And then there's the embedded systems. So embedded C is becoming very popular. There's also courses in PCB design, EMC design. Again, for embedded cores, the likes of ARM Cortex, we have run training courses for that, and a digital signal processing primer course. And then there's some non-technical training courses which are required as well. Often engineers are transitioning to management positions, and some of the so-called softer skills that are actually quite hard are often required, and we often facilitate that as well. So that's a little about the SkillNet. Now I'd like to just talk about the actual topic today. So the skill shortages and opportunities in microelectronics. IC design skills are there's a shortage worldwide. Microelectronics multinationals are competing for talent globally. All IC design center locations within those multinationals compete internally with one another. So if there's a design center in Ireland, it has to make its case for why the next tranche of FDI investment should come to Ireland. So the sort of criteria that the headquarters will look at is first-time right success rate, look at the design expertise, whether there's expertise in specific project areas. They'll also look at productivity in IC design, whether schedules have been met. And there's also geopolitics involved now, and the likes of subsidies from the EU and from the US, which also influence the locations of design centers. So there's a lot of factors there that are influencing where the next investment happens, and Ireland has to try and make its case to win the next investment of FDI. So it's not just about setting up design centers. It can be for the next stage of expansion. For example, some of the ones that Tom referred to there, the 600 extra jobs in ADI in Limerick, and also the expansion at Intel. There's also been, in the last couple of years, there's been a big expansion of Qualcomm down in Cork. Cadence have set up a design team down in Cork as well. There's also Bosch has set up a design team in Limerick. So there's been quite a few announcements. SMEs are always challenged to attract experienced IC designers with this competition between the multinationals. So that's another area that we try to do our best to support SMEs, particularly in ensuring that they have equal access to the training we provide. Specifically in Ireland, well, the skill shortages, we've been doing well in terms of flying the flag. There's been new design centers announced and expansion of existing design centers in recent years, as mentioned. Currently on the Midas Ireland website, there's a job center page, and there's 8 Midas member companies currently hiring for 50 IC design vacancies. So there are plenty of openings there for anyone who is interested. Over half of IC design positions at the moment are being filled from abroad in recent years. So it's not uncommon for some of these new design centers that have been set up that they're bringing in engineers from well outside the EU. They could be coming from India, Asia, Middle East. There's also within the EU, there's quite a few coming from Italy, and a number of other European countries. So there's probably more than 50% of hires at the moment are coming from abroad. So there is a skill shortage, and it's something we'll talk about a little more in the following slides. What it does mean is that there's opportunities for both elect eng grads and for those who want to switch to IC design from other areas of engineering. So the SkillNet can help in actually supporting that. So I mentioned the continuous professional development modules and the subcommittees that set them up. So in the last 5 years, the SkillNet has used these CPD modules effectively to provide induction courses for new entrants into a specific design role specialization. The issues here that there's skills gaps between what graduates know coming out of college at the moment and what's needed for analog and digital IC design. The senior engineers in the design companies at the moment, they're generally very busy, and the mentoring bandwidth that's available can be constrained by project priorities. So the CPD modules offer a method of trying to accelerate the learning curve while also reducing the mentoring bandwidth required, the one-to-one mentoring with the junior engineers. So these induction CPD modules were created to bridge those skills gaps. And we've also built on those CPD modules, we've coined the term learning pathways, so that the CPD modules would be the anchor courses, and that some of the shorter courses that we provide tend to enhance the actual skills around that core area of specialization. These are the 5 CPD courses that the SkillNet has developed to date. So within test and measurement, we've got an analog test and measurement CPD module that was developed in collaboration with the University of Limerick. The digital IC test CPD module is just being developed at the moment, again with the University of Limerick. And the pilot course for that will be in 2024. There's a digital IC verification CPD module that was developed with TU Shannon. And the digital IC design CPD is one of the very popular CPD modules that was developed in collaboration with TU Dublin. And Dick Gann will be talking following myself, so he may give a bit more detail about that. And finally, then there's the analog IC design CPD, which is being delivered by Ken Deavy. So all of those, they're due to run next time in the autumn of 2024, which is generally when we've run those CPD modules. They generally run between 12 and 15 weeks, and it could be between 3 to 4 hours of tuition each week, but there is maybe 6 or 7 hours of self-directed learning in addition to that, with assessments and exams at the end. And they generally lead to level 9 ECTS credits. So I mentioned learning pathways. So each of these CPD modules here, we see the digital IC design CPD module in bold print. Essentially, it's an anchor course for a digital IC design learning pathway. So we think of a new entrant into digital IC design, their trajectories should be from the bottom left up to the top right here. So as they go from 0 up to 2 years or more of experience, we generally see them covering some of these short courses, and essential to their training would be the digital IC design CPD module. So likewise, here's also for a digital IC verification engineer, the digital IC verification CPD module developed with TU Shannon is the anchor course for that learning pathway. And then on the analog IC design training pathway, the analog IC design CPD module is the anchor course there. Okay, so just as well as the CPD modules, they're short courses that they generally can be around 3 days or 4 days of duration. This is a list of some of the upcoming courses, and there's a QR code there, so I'll just leave the slide for a second or two if anyone would like to follow this list of CPD modules, of these short courses. they can just capture that CPD, that QR code, and you'll see the list of upcoming courses on our website. And I'll show this QR code on the last slide again in case anyone has time to capture it now. So just looking at the courses we run, so coming back to the topic of today's webinar, the top upskilling needs in IC design, or the skill shortages that are there, they're on topics like system Verilog and universal verification methodologies for verification of digital IC designs. Python programming has a number of applications in the automation of evaluation and test, and also in data analytics. And then C and C++ for embedded systems are also very popular. And digital signal processing. And yeah, finally, there's also short courses on the fundamentals of digital IC design, also delivered by Dick. And sorry, the other one should read fundamentals of analog IC design. I didn't get to change the text there. So that QR code will be on the last slide again in case anyone didn't get to capture it. So the MIDA SkillNet and microelectronics skill shortages. So how can the MIDA SkillNet contribute to solving the problem? It's a training collaboration for all. So we provide a broad range of specialized IC design courses, which are available regularly. The specialized courses can be run more regularly when all of the companies come together to pool their training needs. It provides equal access for all companies, including the SMEs. So SMEs that would never be able to run the course internally themselves because they mightn't have enough attendees, they can benefit from the frequent reruns of the popular courses and can book a single place whenever they require it. And there's also a low-cost hurdle for best-in-class training. So there's a generous grant subsidy from the Department of Further and Higher Education, and that helps to ensure that the cost is not a factor preventing engineers attending. So no matter what IC design company you're working for in Ireland, you should be able to avail of the MIDA SkillNet training. The SkillNet is also building ties between universities and industry. So the CPD modules are scoped by industry. So it's industry's opportunity to direct the HEIs and to specify exactly what are the priorities in the content of those courses. The SkillNet is also guiding effective L&D strategies. So the learning pathways I mentioned, they're also something that managers in member companies could use at annual reviews when they're talking to their engineers and their team and sort of saying, okay, if you're heading more towards digital verification rather than digital design, then this is maybe the learning pathway, and these are the courses you might want to look at doing in the next year or two. We're also increasing the number of courses that are accredited. We are working to link some of the courses to an initiative between the universities here, microcredits.ie, and we're also looking at special awards, which are, instead of just a complete master's, maybe something that equates to about 30 credits. And finally, we're also working at the moment on a program evaluation to assess the impact. So it's used for companies to know, has the training actually delivered something that does improve the productivity of the engineers. And we can also, from that program evaluation, we can try and improve the quality and the relevance of the training content. So in short, or in summary, the MIDA SkillNet is trying to support the semiconductor ecosystem in Ireland. So this is the last slide. So there's ways I think that maybe anyone listening to this webinar might be able to get involved and try to tackle the skill shortages. So on the top left here, that QR code that will lead you to the upcoming training course schedule that I shared earlier on. And then the next one there, we do, because the SkillNet is industry-led, we survey companies about their training needs. So if your company hasn't participated in the Midas SkillNet training to date, and you wish to provide an input as to what training needs you have from a long list of training courses that are at that link from that QR code, you can enter your email address there, and just give an estimate of the number of places you estimate that you might need in 2024 under the different training topics. There's no obligation involved in providing that training need input. We will just notify you when the courses that you're interested in are coming up, when we're able to run them. If you're thinking of moving into IC design, there are plenty of opportunities, and this QR code, the second one on the left here, leads to the Midas Ireland site, the job centre, and there's currently 50 vacancies advertised there from 8 Midas member companies. And finally, if you're from the university side and you wish to meet the managers of the microelectronics companies and ask them about the skills gaps that they're experiencing, and maybe you have a solution for some of them, the annual conference of Midas is on next Thursday in the Castletroy Park Hotel in Limerick, and that QR code will lead you to the actual details of that conference. So I'll just leave that slide up maybe for a minute, and if there are any questions that we want to take at this stage, I can take them now, or we can take them later, as you prefer.
Thanks very much, Jerry. I think I've got 2 kind of quick ones that we can just ask. That means we'll leave the slides up. This is the first one, more just a slight clarification. I think you did mention it, but do you have to be a SkillNet member to avail of the courses, or is it kind of open to all types of companies?
So the SkillNet, the remit of the grant funding is to upskill employees in the private sector. So as long as you're an employee in any private sector company, even if it's not engineering and you want to do a Python course or a management course, we can facilitate that. We don't have any grant funding support if somebody is a student or not in employment at the moment. But companies don't need to be a member of Midas, the Midas Association. There's the actual training courses are open to anyone from the private sector in Ireland, anyone employed in the private sector in Ireland.
Okay, very good. I suppose just another quick one then. In terms of the CAD tools needed, I suppose to supplement the kind of microelectronics sector, how is that taught, or how does somebody learn those skills in CAD in particular? Because it's quite different, I suppose, maybe from mechanical engineering or.
Yeah. So it generally the multinationals themselves would have selected their own EDA tools provider, and those tool providers have they have their own courses about how to use their specific tools. So the training that the Midas SkillNet organizes tends to be more about generic design skills rather than about the actual usage of specific tools from any single EDA provider.
Yeah, very good. And look, I suppose I'll use this opportunity to introduce our next speaker. I suppose from the HEI or the higher education perspective, that's where you kind of give the broad access and broad knowledge, and then the detail then I suppose is put on top by the companies. So I will thank you, Jerry, and introduce the next speaker, Elena Blokina. She's an assistant professor with the School of Electronic and Electrical Engineering in UCD.
Hey, thank you. I hope you can see my slides. All right. Okay.
Yep, thanks.
And then I will be talking about quantum technology and then education in quantum technology and quantum computing from the perspective of UCD, School of Electrical and Electronic Engineering. So, and maybe just to begin with, just to tell you a little bit of story, like a background. So at the School of Electrical and Electronic Engineering at UCD. So historically, there was a research group looking into integrated circuits and semiconductor devices. And now there is a number of colleagues there, a very good collaboration. And so we would look into device properties, characterization, and then modeling and theory, in particular nonlinear behavior, and then also simulation of devices, algorithms, and signal processing on chip. So it's quite, again, like a team of academic collaborators there. So, and we would, again, kind of look at many aspects of integrated circuits and semiconductor devices. And then relatively recently, not like a few years ago, but maybe already like 7 or 8 years ago, so we started to look at the cryogenic behavior of semiconductor devices and their application to quantum computing. So there was a new process nodes, the new devices, and then, as I will mention later, there's quite a bit of boost from quantum computing. So we would begin to look at single election charge sensors, confinement and quantum transport in transistors, and maybe even how to build a qubit and control. So have like again, I mean, like, some PhD students, postdoctoral researchers, and that's basically why I mean, like, so that's why we had this particular interest in quantum technologies and quantum computing. So just because of this historical background. So some time ago, like just a few years ago, so there was a huge boost because quantum computers, like we entered the stage of scalability. There was quantum computers required control circuitry, particular operation for kelvins, what we call the cryo-CMOS. And then quantum dots and qubits, there was new technology for quantum dots and qubits based on semiconductor devices. And in some cases, you can just use a transistor to build a quantum dot or a qubit. And then again, quantum computers, as I mentioned, are now in the phase of scalability. So we are talking really about like increasing the number of qubits, increasing the computational power. In quantum algorithms and quantum-inspired algorithms, we also found quite a bit of applications to many important and interesting problems as well. So it's quite, again, this boost, and I think it's very much related to semiconductor industry and integrated circuit design. In terms of the actual landscape and kind of ecosystem on Ireland, so Ireland is well connected to European research landscape. There is actually quite a lot of quantum activities going on Ireland as well. So, for example, Equal One Ireland develops quantum on chip scalable technology for quantum computing. There is at UCD multiple colleagues from different schools kind of formed the UCD Center for Quantum Engineering, Science and Technology, where again we are looking for research collaboration and also education in the domain of quantum technologies. So there are a number of European projects where Ireland participates. For example, Quadrature is a European Union funded project on scalable architectures for quantum computing. There is also National Enterprise Ireland funded project to support and develop quantum landscape in Ireland, and IBM, Equal One, MasterCard, Tyndall, UCD, Minor University, so we will participate in this project. There is actually a really good research community, many excellent research teams and groups in Ireland. I just mentioned only a few examples, but there is more examples, of course, and of course, working in theory, modeling, algorithms, and devices in Ireland. So for us, the motivation to develop quantum modules, quantum engineering and quantum computing modules, that's because if you look at the proposed quantum computer architecture, which I show here on the slide, you will see there is multiple layers. So there is actual quantum chip or qubits, and then there is a quantum to classical control, microarchitecture, quantum instruction sets, and so on, up to quantum algorithms levels. In each of the levels, you kind of can correspond it to, let's say, applied physics or semiconductor physics, and then there is layers that you can associate with electronic and computer engineering, and there's, of course, there is software engineering and computer science. And it's a truly kind of multidisciplinary area. It requires multiple skills, and it's a lot of that is semiconductor physics and electronic engineering, and kind of and of course I'm looking again at the level of algorithms, computer science. So from the perspective of software engineering and computer science, there are questions. Community would be very interested to know, so what are quantum algorithms, what problems we are solving, where to apply quantum algorithms, and kind of again how to optimize quantum algorithms depending on the problem at hand. And then from the perspective of electronic and computer engineering, you may ask a question, so how to control quantum devices, how to build circuits, what circuits are required, how devices and circuits behave at cryogenic temperature. So, and again, I'm looking at how we build the ultra low power design and so on. And finally, again, if you're, let's say, someone kind of, as an engineer or physicist working with devices and semiconductor physics, you may ask a question, so how to build a qubit? So how to make a qubit like a coherent or kind of, high quality qubit, how to control qubit, and then how to build, let's say, quantum sensors or quantum state sensors. So these are all the questions, kind of, these are all very emergent, like very new questions, and it's motivated us to build, kind of, to bring in, like to develop new modules in this domain. So at the moment, we have two of them, Introduction to Quantum Computing and then Quantum Computing. I'm just giving the UCD code numbers. If you just search for these code numbers, you will see a full description. And again, I'm looking at the structure of the module. So, and the questions we ask is how to approach teaching a research intense topic like quantum computing and quantum technology, and what's the best style to deliver the materials. So again, I mean, like, it's not only just for, let's say, undergraduate or postgraduate students, but it's also suitable for professional learners. So, and we developed these modules based on our own research experience. So, for example, the Introduction to Quantum Computing module, basically from no or little background in quantum computing or physics, students will be able to design and model very basic variational quantum circuits from basically, again, no knowledge to some very, very simple algorithms, quantum algorithms at the end of this module. And then for the second module, more advanced module, quantum computing. So we begin with some understanding what a quantum circuit is, and then we actually develop elements of quantum information, coherent and more complex algorithms. So at the end of the module, so students are able to design much more complex algorithms and also run realistic simulations. So generally, these modules are not only for engineers or kind of computer scientists. So our current class has a very diverse educational background. So there are students in physics and students in mathematics and computer sciences and electronic engineering, and also mature students and also professional learners. So it's really for a general STEM background. It's kind of not kind of exclusive for kind of aimed at a particular, let's say, cohort of students. So maybe just to give you an example of Introduction to Quantum Computing, because that's the module we run this semester. So you can see like let's say a snapshot of, so it's designed in a little bit unusual way, in a way, okay, so it's designed as a level 4 master's, like kind of level module. And it has a standard workload, like 120 hours, so standard credits and kind of similar to all other modules. But it's designed to be a hybrid module. So, for example, we have no formal lecture hours in this case, but we do have class time. This class time is in class, and we also broadcast broadcast lectures and kind of tutorials through Zoom. And then in the class time sessions, it's a mix of different materials. So we do some recap of theory, and then and we solve examples. We rely a lot on Python programming. So then we would go through Python scripts. We explain how to program different problems, how to see kind of numerical solutions to the examples, and so on. So we provide homework overview and we give group feedback. And one of the features, so we try to invite guest lecturers from industry. So this year we have 4 guest lecturers given invited talks on quantum machine learning, Qiskit, algorithm complexity, and then quantum processor architectures. And Q&A is a normal part of this type of workshop and tutorial session. So for us, when we developed this module, kind of encouraging the class to ask questions was very important, because if someone asks a question, it means there is an understanding, like so this student begin to understand in the development. So we encourage, we really want students to ask questions and seek connections with other modules at UCD. For example, again, if you start with Introduction to Quantum Computing, after that you can take Mathematics of Quantum Computing or Quantum Machine Learning, or again, kind of, proceed with our own, like our school's quantum computing module. So it's a stepping stone to take other kind of, advanced modules in this domain. It's being a hybrid module that someone can study in class, or let's say, or like a full Zoom. Okay, so we used multiple tools to develop the materials. For example, we use Brightspace, and Brightspace is a UCD main tool to manage the content and materials of the modules. So if you're a student in this module, you'll open the Brightspace page. You will see kind of, links on the lectures, videos, lecture notes, homework assignments, and so on. As I mentioned, we rely a lot on actual programming skills. So we designed Jupyter notebooks, and we run them through Google Colab environment. So there is no need for installation of, let's say, Python on the local computer. And then for each of the topic, we have like this Jupyter notebooks that, again, a student can access. So in LaShek and Overleaf, we design lecture notes. So you can download a full set of lecture notes, which is almost like a mini book, basically, with all the detailed descriptions, formulas, examples, and so on. And during class, we use Nearpod or Google Slides to kind of, to ask questions, to ask, to kind of run a Q&A sessions, and so on. So that's a lot of tools used, but like, I think in the end, again, everything is managed through Brightspace. And once if I go back, like, for example, once you open a Brightspace, you will see this type of like, let's say, a table where each week is each topic, and then you will see video, handout, tutorial, homework, reading, and milestones. And I think this modular design is really good, in particular if someone is a professional learner, if someone has connection online. So it means, so it kind of gives a freedom to teach also in class and online. Okay, so maybe a little bit of outlook. So developing and teaching this research module was a really interesting, great experience for our school. It's a part of our research activity. It's a part of our research experience. It's very important for us to translate it into a module. And then we also think, so again, for these advanced modules, so we try to experiment with different delivery styles for these research-oriented modules and materials as well. So we are going to see more extensive feedback this year, because this year class is relatively large. So it's not the first time we run it, but like, it's just like the class is quite large. So we are very curious to see what's the response and to this let's say, kind of, delivery style. So we're considering other modules, like in particular, maybe like something related to advanced semiconductor materials and quantum properties, or maybe quantum transport. It's at the moment like under discussion. And as was mentioned, so if you take, if a student takes a number of modules, so it's possible to get a professional diploma. For example, you can design, you can choose a module related to computation and maybe software engineering oriented, or maybe like more to applied physics and quantum computation. So, but it's now within the professional diploma in quantum engineering. So yeah, that's, I think, all I wanted to say in this case. Okay, thank you.
Thanks very much, Elena. I think we're quite tight on time. So in terms of the questions, we will get in touch with people afterwards and send them on. I think I'll just try and introduce our next speaker so that he gets to try and get through some of his content. So Richard Gahan, who is a lecturer in electronic engineering in TU Dublin and based in Tala, I think. So Richard, we'll get you to join us.
Okay, I'll just share here. Okay, can you see my screen?
Yep.
Okay. Okay, so yeah, I've been delivering the digital design CPD module for the last 4 years. So I have 5 minutes, so I'll try and get through this as quickly as I can. So basically, what is CPD upskilling? So obviously, it's completely different to short courses where the participants just attend and listen and interact a little bit. So in the digital design CPD, we have it as a 10-credit module. So we're talking about 200 plus hours of participant effort. So it's not something to be kind of undertaken lightly. but it does prepare them to be productive professionally as digital designers. And even if we look at this 200+ hours, we're talking about 5 weeks of a normal engineer's time over, compared to like many years of experience. So still quite a short amount of experience that they're gaining. So that consists of roughly about 36 hours of lecture tutorial where we work together through many design problems. And the participants would be partaking of those, and we interact live on air during those design problems. And then the students get assessments or assignments to do, which are design projects and design problems, and they work on those for a number of weeks, and then they submit their effort, and then they get not group feedback, but they get individual feedback. Everyone gets at least a page written up analyzing their submission and directing them to areas that they can improve on. And then for those who don't want to commit this kind of effort, but they do want to get an idea of what professional digital design is, we have short courses. So this is about 20 hours of exposure, 5 days, 4 hours a day, with the afternoon free, so that the participants can themselves work more on many projects and problems. And at the end of it, to become aware of what digital design is, and it can be useful for managers and engineers to test the water. So over the years, this is what we've achieved. So in 2020, we have about 20 engineers that done the CPD, about 24 that done the short course, and then similarly for 2021, 22, and 2023. And at the moment, we're in the middle of the CPD module. So it's quite a lot of engineers pushed out into the industry that have come from knowing almost nothing about digital design or Verilog. So as part of the CPD, they also get to know the essentials of Verilog enough to code their designs properly. And that's different from just a Verilog syntax course that doesn't teach how to use it, it just teaches syntax. So I focus on how to use it in a non-complex way. The overall feedback has been positive. Obviously I get feedback from my students and participants, and almost universally positive. Why was it successful so far? Well, it was a need that that the industry identified and we responded to. We had a focus group to inform the syllabus in conjunction with the lecturer. I mean, I've worked in the industry myself for 20+ years, so I know what the needs are, and I've hired graduates, and I've hired other people, and so on. There were industry champions that push the course then within their own company, so they see the importance of it, so they push it. And there was the interaction between academia and industry was easy because I've lived in their world, but I can bring together the education experience about what can and cannot be taught, what can and cannot be achieved in such a course. So generally, who's attending? So we got quite a few graduates. So they have been exposed to some amount of digital design in the undergraduate program. So they learn a little bit of Verilog and a little bit of design, which is good, but very little really can be done at the undergraduate level. It's very small little pieces of it. So they change from being just being aware of digital design to becoming professionally productive much quicker. And then we get a lot of verification engineers and or analog design engineers who may want to do some digital design or may want to be able to talk to digital designers, and then managers who want to help out engineers and set schedules. And then for the future, I think a CPD is a good idea for the big skills, things that participants want to use every day. And I think there are many areas that this can help out on, and we can have the number of credits matching what is needed, 10 credits or 5 credits. And it requires detailed collaboration, and it needs a visionary within the industry to pull out what we need. Okay, that's it. Sorry, I only had 5 minutes.
Thank you for that. Just waiting on my camera's just kicking in again. Look, appreciate you're a bit squeezed there, so a little bit of a whistle stop presentation on all the good work that you're doing. And I suppose Jerry pointed out just some of the crossover there with SkillNet as well. I'm just going to bring in Peter Kennedy. He's a professor in microelectronics in the School of Electrical and Electronic Engineering in UCD to give us a closing remark. And if there's any other questions, put them into the chat and we'll send them around to the speakers afterwards. Thanks.
No, I just want to say a huge thank you to our speakers. So Tom, I know Tom for many years, worked with them since 1995 in various aspects of the electronics business. And he has given a fantastic overview. For those of you who aren't so familiar with it, there are so many opportunities. I mean, this is a business that continues to grow, and there are more and more jobs and opportunities every day. Now, part of it is that it was always said you won't have a job in electronics, you'll have a career. But part of that career is continuous upskilling. And I think from the industry lobby group, Midas Ireland has worked very effectively on this, and Jerry has done a fantastic job in defining the needs of the industry and then getting the relevant courses prepared and getting people through programs, getting the funding for that through SkillsNet. So thanks, Jerry, for the great work that you're doing. Then from Elena, there's new stuff coming. In the quantum area, and we've all been a little taken aback by how fast the take-up has been on the new modules that have been developed. We can see that there's a huge interest in this topic, and that's fantastic to see. And then finally, we heard from Dick. Dick, it's a fantastic success story of how to work with industry to develop a product that is designed for customers and to work very closely with those customers. So the product, the training is kept up to date and serves everybody's needs. So well done to all, and thank you all for participating in this forum. Back to you, Barry.
Okay, thank you very much, Peter. I think you've summed it up nicely. I think we're running a little over there, so we'll let everyone get back to their Friday afternoon, and just like to thank our speakers. It's an interesting topic, and I think definitely an area that has a very broad skill remit. So hopefully you've got a bit of an idea of what's going on nationally and locally in this area. Okay, thank you very much, everyone. Have a good Friday.